All right, what to do, everybody? Happy, whatever today is. This is our calculus video. This is the beginning of Unit 2. And Unit 2 begins with limits. Limits. It's a major part of calculus, and so we have to know how to work with them. Before I get into them, let me kind of briefly explain what a limit is. So if I have some function, I'll call this function f of x, and f of x does all sorts of different things. So if I feed it an x value, let's say I feed it the value 3, many times it has a y value coming off of this, such as I'll call it 5 or something like that. So if I feed it 3, it spits out 5. So in essence, f of 3 is equal to 5. Now, what happens when I want to talk about a limit? A limit is not an actual point on the graph itself. It is not an actual point, but rather what a limit is and how it's going to look is like, what is the limit as x goes to 3 of our function? This is kind of what it's going to be. Now, again, it's not asking you where is the point, where is the physical point, but rather the limit is saying, what does the line leading up to it imply that the point should be? All right, so here, again, yes, because the line on this left-hand side and this line on this right-hand side are both kind of converging at 5, that means, yes, the limit of f of x is equal to 5. But does that have to be the case? No, that doesn't have to be the case. Let's say, for instance, I have a picture that looks like that. Okay, where there's a hole in the graph. There's nothing there. So you cannot say f of 3 is equal to 5. You can't say that. That's not true because there is no actual point. So f of 3 is undefined. There is nothing there. It's not defined to be anything. All right. However, what is the limit as x goes to 3? And again, the limit does not actually have to have a point. It's just asking, if I take a look at this line left and the line right, do they converge on a singular point? Yes, they do converge on a singular point. So what are they predicting that the point would be? They say it should be 5. And that limit is still actually true. So a point does not actually have to exist. Okay, so that kind of graphically is what a limit is. When you do it on equations and things like that, though, you don't, it's pretty basic. And I'll kind of explain myself as we go through some of the problems today. But really, all that you have to do when you take a limit of something, okay, is pretty much do a substitution. All right, so if I have the limit as x goes to 3 of x plus 2, in essence, what you're doing is you're making that x the number 3. And so this problem, as limit goes to 3, would be equal to 5. All right. However, sometimes you're not able to just basically substitute in. You're not allowed to do that. Like, so for instance, in here, you cannot just basically substitute a 3 in for x, because that denominator would become equal to 0. Illegal mathematics. You can't create illegal mathematics. So instead of creating illegal mathematics, what you have to do in the world of limits is if something like this is created, chances are the problem can be simplified. And so what you do is you write down, okay, I'm still needing to take this limit. You'll notice that the numerator is the same thing as x plus 3 minus 3. I can factor it. And you'll notice that if I do a basic substitution or a basic elimination and factoring, a lot of times you create a problem that is now non-illegal mathematic-ish. So this, I can now legitimately put in the number 3, and I will get the number 6. Okay, so this is equal to 6. So if you see illegal mathematics, chances are it can be simplified, it can be changed in some way. Also, you physically have to keep writing down the limit as x goes to 3, or whatever the limit is, until you physically actually do that substitution. All right? So if I saw the problem and it said this is wrong. This is incorrect. Okay, this is incorrect because you physically have to write the limit as x goes to 3 until you physically make that substitution. All right, on to the problems, Again, most of these are just basic. We're just going to substitute in this x value, and we are going to find the limit. So in problem number 5, I can basically substitute in for that x. So I'm substituting it again. This is where I'm getting the x. So that x goes to 2, and so this will be x to the 3rd, which is equal to 8. Okay. Thought I messed up there for a second. So again, no illegal mathematics. Here we get into some trigonometry right here. Don't forget about your unit circle. Your unit circle will help everything out. So here, this substitution is sine of pi over 2. Again, on the unit circle, the x-coordinate is cosine, the y-coordinate is sine. It goes cosine sine, so this would be equal to the 1. Anything to the 0th power is equal to 1. So e to the 0th power is no exception. That is equal to 1. That doesn't get pretty. That's a nasty answer. So when you get nasty answers, just leave it in, like, you know, the mathematical form of it, not what it's actually equal to in the decimal, unless they very specifically ask for that. These number 41 is trying to get you to use ideas of limits, like what things that you can do with limits, like how they may look a little goofy to you. And your intuition is probably correct on these things. It's you can just pretty much split them apart. So for instance, when you have a constant, it's a constant times the limit. Okay, it's not a big deal. I'll come back to these. Addition, again, is the addition of the individual limits themselves. So if you have f plus g, then it's the same thing as f plus g. F times g, you guessed it, is still f times g, but just of the individual limits. Again, I'll come back to all of these. And division, again, is just a division. All right, so going back to the very tippy top where we see that the limit as x goes to c of f is equal to 3, and the limit as x goes to c of g is equal to 2, then we're able to actually physically do these problems. I'm not exactly sure what they're looking for in number 45. I'm sure they're trying to. I'm not actually. I'm not sure what they're trying to do. I'm not sure. Like, but I know what they're asking. Don't worry about 45. 47. 47. I know what they're trying to imply. So what they're trying to talk to you and teach you about in these problems, 45 and 47, et cetera, is I can't use the equation that they give me because there's illegal mathematics inside of it. So I can't use that equation itself, but rather I need to simplify it. So going back to my notes here, the idea is what they're trying to teach you is this idea right here, where you have to simplify before you're actually able to take the limit. That's what they're trying to teach you with these problems. And I'm not exactly sure what 45 is all about, but so in this one, I see that the numerator can be factored. Okay, so don't forget to write the limit again. We're not taking any limits just yet, but I see that a squared, like a difference of squares, is square root plus and minus. So it's x plus 1, x minus 1 as the numerator, and then I have plus 1 on the denominator, and huzzah, now you have legal mathematics. You're able to actually put in a -1 for the x. So this, now I'm able to put in the -1. I do it so I don't have to write the limit, and so this is just straight up -2. Okay, again, illegal mathematics, so I'm not taking the limit just yet. I'm just going to factor the equation. So I can GCF out an x in the denominator. Now this simplifies. And so now I'm able to put in the 0 for all the remaining x's, and this would be 1 over -1, which is equal to -1. Okay. Next. Again, simplification process. All the factoring skills. I think we all took Algebra 2, right? Number 57 is a little bit confusing. When you see like something like that numerator, it's kind of a tip-off that you're going to have to multiply by the conjugate of it, which is everything stays the same except that middle symbol, in this case the minus, turns into a plus. If there was a plus, turn into a minus, and what that does is it simplifies the process, and sometimes things work out. So you'll see what I mean here in just a second. Okay, so what I'm going to be doing to this is I'm going to be multiplying by the conjugate, aka the square root of x plus 5 and 3, but the minus is now a plus. All right, so this is that. So what is yielded in the numerator here? Okay, so you kind of have to do this as a distributive property. So I'm beginning with this very first square root of x plus 5, and it multiplies through. So that will produce a x plus 5. Okay, on that multiplication, it will create a positive 3 square root x plus 5. But notice on the second part of this multiplication, you instantly create a negative 3 square root. So the positive 3 square root x plus 5 is instantly eliminated with the negative 3 square root x plus 5. And then all that's left is the negative 3 and the positive 3, which is a negative 9. Okay, so that is the numerator. The denominator is nothing good looking, so what I'm just going to do is I'm going to keep it as separated. I'm not going to actually try to do any math with it. Yeah. Okay, so continuing this on, I noticed that, again, I haven't taken the limit yet, so I still have to keep writing it. I noticed that the numerator is now x minus 4. Haha. Because I have an x minus 4 in the denominator. Funny how that works out, right? So now I see that there is a simplification with the x minus 4. Now it's absolutely legal for me to be putting in that 4 for my x. So the denominator is no longer a 0, it's something. So I can plug it in. So 4 plus 5 is 9. Square root of 9 is 3. 3 plus 3 is 6. The denominator was canceled, aka that's 1. All right. well, there's silly things that you need to know. Limit as x goes to 0 of a sine x over x is equal to 1. Let's take my word for it. So notice that in this problem right here, I can factor out a 1/5 before the operation is even started. Okay, so 1/5 can be started, and this is a version of 41 letter A. 41 letter A is a similar problem. Okay, so that is the idea behind it. And knowing that sine x over x is equal to 1, so this is equal to 1/5 times 1, which is 1/5. Sine x over x is equal to 1, so this is the same thing as saying limit as x goes to 0 of sine x over x times sine x. Okay, times sine x, all with the limit going to 0. So the first bit is equal to 1. So this is 1 times sine of 0. Sine of 0 is 0. I know it's not a straight up multiplication. I'm just going to kind of cut to the chase. This is 3 over 2. Look at the book. The book explains it a little bit better than I am. The huge tip off is if you see something in this version, like, so in the limit is going to 0. And so if this were like 7 and this is 2, then this is going to be 7 over 2. That's kind of how it is. All right. We're close to the end. So these are exam preparation questions. This looks like something that I probably no, I don't have to factor. I can straight up put in a 2. There's no illegal mathematics in here. So the denominator is 2, 8, 16 minus 25, which is negative 9. Right. And the numerator is 2 plus 1, so that's 4, 8 minus 6 plus 1. So that's what, 3? Okay, here I cannot put in the x is equal to 3 because it creates a bottom 0. So limit as x goes to 3. This is a square, so this is x squared plus 9 minus 9. Getting closer. I can't break apart the difference of a sum, so that means this x squared plus 9 has to say x squared plus 9. However, the x squared minus 9 is a plus 3 minus 3. All right, there's the cancellation that I was looking for. Now it's legal for me to be putting in the 3. So this is 9 plus 9 and 3 plus 3. So whatever 18 times 6 is, so that's what, 40, 100? That's stupid, no. Is it 18 times 6? 40. 108. Oh, it does, 48, 48, and then, yeah, 108, done. There you go, kiddos. So the big part of this lesson is the idea of for a limit in an equation, just try to do a basic substitution. If a basic substitution doesn't work, then go ahead and you'll probably have to factor and simplify in some fashion.